In our notes yesterday, we talked about two formulas specifically, which are the two up here on the board. Over here to the left, it's compounding at a specific interval. What that means is, well, as we look at the variables in here, A is the total amount. P is the principal amount, what we're starting with. R is the interest rate, expressed as a decimal. T is time. And then the N, the one that I just skipped over. N is the number of times that interest is calculated. And we have some different time intervals that we looked at yesterday in our notes. The first example that we did was a yearly. That means that interest is calculated once per year. Then we did semi-annually, which means that interest is going to be calculated twice a year. Quarterly is going to be 4 times a year. Monthly, which is probably the most common, I like it, is 12 times a year. And credit cards like to do monthly. But the other formula that we used is this formula to the right called compounding continuously. In order to use this formula, this word continuously must be in the problem somewhere. It specifically has to state continuously. A is still the total amount, P is still the original amount, R is still the interest rate, T is the time. We don't have N in this formula. And then E, if you recall, is a number on your calculator. It's 2.718. It's just a button that's on our calculator. And today we're going to use these two formulas to kind of apply everything that we've done, or a lot of what we've done in this unit, to help us solve some problems. So for the problems, what we can recommend that you do is first figure out which formula we want to use. Then we're going to solve for the missing variable. We want to show all of our work that leads to the solution. Do not round any values until the end of the process. And then at the end, we're going to round to the nearest thousandth, 3 decimal spaces. So our first problem says you deposit $1,200 into an account that earns 3.6% interest, compounded continuously. There's that word, continuously. And the second that we see that word, we can identify that we're going to use this formula that's to the right, right above on your paper. Sometimes people call it PERT. It's an easy way to remember the formula. Then it says, how long will it take for the amount in your account to double? I want to circle this word double because this is an important word in our problem as well. But what I personally like to do, and it doesn't matter to me whether you do it or not, is I like to identify what we know in a problem. So as we start here, we deposit $1,200. That's our original amount. Into an account that earns 3.6% interest. That's our rate, which is 3.6%. How do we write 3.6% as a decimal? 0.036. And it says, how long will it take? So we don't know time in this problem. That's what we're going to try to find. How long will it take for the amount in our account to double? Well, we don't know exactly what A is, but we can figure it out. It says double. We started with 1,200, so how much is double that? It's 2,400. And where that came from is it came from 1,200 times 2. That's where that value came from. So it's not specifically stated, but we can figure it out. And now that we figured it out, we're going to put those values back into our formula. 2400 equals 1200 E to our rate, which is 0.036 T. And we want to solve this. And the first step in solving is the fact that we need to isolate. And I write that kind of small, because maybe you need to write that down to remind yourself and maybe you don't. But to isolate the variable, we're going to divide both sides by 1200. When we divide both sides by 1200, we end up with 2 equals E to the 0.036 T. And now we can solve. And when we do, I'm going to use ln. If you like log, if you like the common log, there's nothing wrong with using it. The reason that I choose to use the natural logarithm is because the natural logarithm has a base of e. That's the only reason. You do not have to choose it, but when I see e, I automatically think natural log. This is going to be the natural log of 2 equals the natural log of e to the 0.036. So once we get that natural logarithm in, we're going to use our power property, which says we can take this 0.036t and we can write it out in front of this logarithm. So it's going to be 0.036t times the natural log of 2 and the natural log of e. And remember, one more thing in our direction says, don't round until the very end. But we're still in this isolation process. We want to solve for t. So our first step is going to be that we're going to divide by the natural log of e on both sides. When we divide both sides by the natural log of e, we'll be left with 0.036t over here on the right side. And I'm going to type it in. Natural log of 2, close the parentheses, divided by the natural log of e. Close the parentheses. I did second division to get the e. If you have an Inspire calculator and you use your e button, you have to put an exponent of 1 in on the Inspire. You have to. So once we get that, we press enter, and we get this big long decimal. And I'm going to round it for now, 0.693, but leave that number in your calculator. So this is 0.693 over here. To finish, it's 0.036 times t. We're going to divide by 0.036. And we already have that number left on our calculator. We're going to type it in. 0.693 divided by 0.036. And when we press enter, we're going to get our value. When we round it here, we're looking at the 4th decimal space, which is a 0, which means that we're going to keep that 4 in there. We end up with 19.254 years until we can double our money. A fairly long time, and it's a fairly reasonable question because the interest rates in our economy right now are pretty low. In fact, 0.036 or 3.6% is probably a good interest rate at a bank right now. That's a little bit high. But again, what we're doing is we're applying everything or a lot of what we've learned in this unit to helping us solve these types of problems. Problem number 2. We're going to deposit $1,200 into an account that earns 3.6% interest compounded quarterly. I emphasize quarterly because that's an important word in this problem. It tells us which of our 2 formulas at the top of our page here we're going to use. And the quarterly goes with our left-hand formula, which is A equals P times 1 plus R divided by N to the NT. Well, it's quarterly, so we determined which formula. The question now says, how long will it take the amount in your account to triple? So let's write down what we know. We know P, the 1,200, is how much we're going to invest. We know the 1,200. The next part says our rate is 3.6%, but how do we write 3.6% as a decimal? Well, we move our decimal 2 spaces to the left, so it's going to be 0.036. N comes from the quarterly. And quarterly means that interest is calculated 4 times per year. It says how long, that's time. We don't know what time is. It says how long will it take for our amount to triple? Well, that's going to give us our A. And what we're going to do is we're going to take 1,200 and we're going to multiply it by 3. Because triple means 3 times, and we get 3,600. So there is everything we know about the problem. And now we're going to put it into our formula to help us solve. 3,600 equals 1,200 times 1 plus our rate, which is 0.036 divided by 4 to the 14th. Looks fairly complicated. It's not as bad as it looks. The first thing that I want to look at is the parentheses. And sometimes this works and sometimes it doesn't work. But I'm wondering if we can simplify what's in the parentheses down a little bit, because we don't want to write that over and over and over again. And sometimes we don't have a choice. But on this particular problem here, when we look at our parentheses, it's 1 plus, and you don't have to have a calculator there, 0.036 divided by 4. When we type in enter, we get a simplified version, which is going to make this a lot easier to write. We still have 3,600 equals 1,200 times 1.009 to the 14th. And we're going to have to isolate. And that means that we're going to have to divide both sides by 1,200. We want to try to get the variable as much by itself as possible, and the variable is an exponent. Divide by 1,200. And I don't know if you need to type that in or not, but 3,600 divided by 1,200 is 3. And we've got 1.009 to the 14th. We have the variable isolated. And now that we have the variable isolated, we can put in our logarithms. This time I'm going to use a common log, which is log. Do you remember what the base of a common log is? 10. But we have 1.009 to the 14th. Our next step, power property of logarithms, says that we can take the exponent, instead of having it as an exponent, we can write it as a coefficient. So that means we've got log of 3. Do I need more space? 4t log, we'll get this in there eventually, log of 3 equals 4t times the log of 1.009. And you can put the parentheses in 1.009, you don't have to. But this is 4t times that logarithm. So our opposite operation is going to be to divide by log of 1.009. If we divide the right side by 1.009, we're going to divide the left side by 1.009. But we need to be careful. We're going to write down a number, but we're not going to round it. We're going to leave this number in our calculator. It's going to be log of 3 divided by log of 1.009. Gives us a big long decimal. Leave that number in your calculator. So 122.616 or so. 122.616 equals 4t. We don't want to round to the very end. We have that number in our calculator. This is 4 times t. Our inverse operation then is going to be to divide by 4. And when we do, we'll end up with t equals, take the number that's in your calculator, just press divide 4. There's going to give us our big long decimal, which we're going to round to the nearest thousandth. And we're going to have to look at the 1 to determine whether we round or not. 1 is 4 or less, so it's going to be 30.654 years. It's going to take a long time for us to triple our money. As we turn our paper over, stepping away from money just for a moment, we've got a population. But if a population started with 20,000 members and it grew continuously, always looking for that word continuously. Because if we see that word continuously, it's going to be PE to the RT. Grew continuously at a rate of 10% per year, how long would it take for the population to double? So, very similar to example number 1. Let's write down what we know, starting with the fact that our initial amount is 20,000. Our rate is 10%, and we need to convert that 10% to a decimal, which is going to be 0.1, 0.10 if you prefer. How long would it take? We're trying to find time for the population to double. Again, another important word. It doesn't come right out and say it, but if the population's going to double, what's our value of A? 40,000. We take 20,000 times 2, there's the double, to get to 40,000. And then we're going to fill in what we know. 40,000 equals 20,000 times E to the 0.102. We can solve this now. We know from the previous 2 examples that we need to isolate. So we divide both sides by 20,000. And when we do, we get 2 equals E to the 0.10t. And once we get it to here, A lot of you are probably even working ahead of me. I'm going to use natural log. You use natural log or common log. But I choose to use the natural log because there's an E in the problem. We put a natural log in both sides. Then we're going to take our power property. And that says that we can rewrite that 0.10t, our exponent, as coefficient. So we still have the natural log of 2, and we've got the natural log of e. Once again, we're going to have to leave that number in our calculator as we go through solving for t now, because it's 0.10t times natural log of e. So we're going to divide by natural log of e. We're going to get a big long decimal. When we type that in our calculator, we're going to leave that number in our calculator. But we still have 0.10t equals. So natural log of 2 divided by natural log of e, second in the division bar. Once again, in Spires, your calculator automatically comes up with e to an exponent. You have to fill in the 1 as an exponent. So once we get that, here comes our number. Just going to write down 0.693. We're not going to round. We're going to leave that number in our calculator. So 0.693 here. And then it's 0.10 times t. So we're going to divide by 0.10. We've got the number in our calculator. So we're going to divide by 0.10. And now we can round. Put that in here. So we're looking at the 4 here to round. It's going to take us 6.931 years for the population to double. So fairly quickly there, because the rate was 10%. Jay-Z has $220,000 to invest, but he needs to have $300,000 in 4 years. What annual rate of return, in other words, what interest rate, will he need to get in order to accomplish this goal if interest was compounded continuously? Again, that word, important, because that word tells us that we need to use A equals PE to the RT. Write our solution as a percent. That's the one thing maybe that will cause us trouble if you're doing well already. But our P is 220,000. And maybe at the beginning you needed to write them all down, and maybe you don't need to write them down now. You can just fill them in. What works for you? And he needs to have 300,000 in 4 years. That's our A. We didn't have to double or triple this time. And we know our time is 4. That's different. We haven't had that before. What we don't know is we don't know our rate. And once we identify those facts, we can put them back into our equation. 300,000 equals 220,000 e to the r. We don't know the r, but we know that t is 4. We've got 4 years to invest. Isolate the variable. Divide by 220. And the issue on this problem here is that we don't get the nicest of decimals here when we divide. I want to show you something on a calculator. 300,000 divided by 220,000 gives us this big long decimal. A decimal that we don't want to write down any more than we want to write 300,000 divided by 220,000 every single time. We can make it a little bit simpler. And by the way, Inspires, you should already have this number on your calculator. But the rest of us, what we can do is we can hit Math, Enter, Enter. It's taking the decimal and converting it to a fraction, which makes that number 15/11 a lot easier to work with than writing 300,000 divided by 220,000. Whatever works for you, but again, to make it a little bit simpler, I'm going to write 15/11 equals e to the 4r. And notice I switched the order on there, which we're allowed to do. And now that we have that, just like our previous problems, we can put in a natural log over here and a natural log. If you prefer, use the common log. It doesn't matter to me. But we have natural log of 15/11 equals the natural log of e to the 4r. And the steps might be getting redundant at some point. I hope so. We're taking this 4r, using our power property. We're going to write that as an exponent here. We still have our natural log on both sides. So it's going to be the natural log of 15/11 equals the natural log of e. Well, it's 4r times the natural log of e. We're going to have to divide by the natural log of e. And that cancels out. We're going to get this decimal on our calculator that we are going to keep in there. We still have the 4r. To type it in. Natural log of 15 divided by 11. We don't have to have a fraction button to type it in. Close the parentheses. Divided by the natural log of e, second division. Inspires, remember, put your exponent of 1. Then we get this big long decimal here, which I'm going to write down 0.310. Keep that number in your calculator. 0.310. And now we can finish, because it's 4 times r. We're going to divide both sides by 4. We already have the big long decimal in our calculator. But remember our last step. If you're getting ahead of me, we want to write this as a percentage. We're going to divide by 4. Gives us that value there. And as we look at the number, we're looking at 5 to determine the fact that we're going to round. So we get 0.078. Because 5 is 5 or higher, we have to round that 7. 0.078. That's our percent written as a decimal. Well, what is it written as a percentage? We need to take that decimal point and move it 2 spaces to the right. And we end up with 7.8%. Again, a good percent right now in our economy. It would be worth investing in. As we finish, how long does it take to double an investment if you can invest it at 0.92% compounded monthly? So all the way at the end here, get one of the keywords, which is monthly. And we don't have very much information. But one thing that we do know by the monthly is that we're going to use A equals P times 1 plus R over N to the NT. And what we know is we know 0.92 So we know our rate is 0.92. And if we write that as a decimal, we have to move our decimal 2 spaces to the left. This is 0.0092. We know compounded monthly, that's going to be our n, and there's 12 months in a year. That's all we know. But let's go back and look at problems 1, 2, and 3 for a minute. When we look back at problem 1, we want to double. When we isolated, by dividing 2400 by 1200, we got 2. And doubling means 2. On problem number 2, we had to triple. When we isolated, we took 3600 divided by our 1200, and look what happens. We got 3. On 3, we were doubling our population. When we took the doubled, we took 40,000 divided by 20,000, we get 2. There's our double. So even though we don't have any specific amounts in this particular problem, what we can do is we can pick a number for P, and we can double that number for A to solve this. Now, I like to keep it simple, but I know some people always like to pick 100 and 200. But I like to say, well, what if I make P 1? And if I double the number 1, then A is going to be 2. And what we're trying to find is how long. We don't know the time. So I think we have everything here. And we can fill this in. It's 2 equals 1 times 1 plus 0.0092 divided by 12 to the 12t. Now, unfortunately on this problem, when we simplify that parentheses, it's kind of ugly. But if we can, I like to do it. It's 1 plus 0.0092 divided by 12. Gives us this big long decimal. I don't know, I now that I'm thinking about it, I didn't try to do the math enter. And it's not going to give us anything that we can work with. So this time we can't condense it down here. So I'm going to leave it. But we can still go through the isolation process. We can divide both sides by 1, which is something that we don't really need to do. But we end up with 2, wrong color here, but 2 equals 1 plus 0.0092 divided by 12 to the 12t. And for most part, and I might be completely wrong, but for the most part, the hardest part about this is how much we have to write down. It's not the solving. We've been doing enough of this that I hope that makes sense to us. But once we get this isolated, and we do have it isolated, we're going to put a logarithm in, and I'm going to use log. Both of them. So it's going to be log of 2 equals log of 1 plus 0.0092 divided by 12 to the 12t. Well, our next step is to deal with that power property. We're going to take this 12t. I'm going to write it out here in front. So it's going to be 12t times our logarithm. Again, the hardest part on this problem is writing out the work. 1 plus 0.0092 divided by 12 It doesn't, it's not a negative, and I can't erase that right now, but it's 0.0092 divided by 12. And what we can do is we can divide both sides by log of 1 plus 0.0092 divided by 12 here. And over here we divide log of 1 plus 0.0092 divided by 12 here. And that leaves us with 12t over here on the right side, because all of that canceled out. So typing it in, we're going to have to leave that number in our calculator. So it's going to be log 2, close the parentheses, divided by log of 1 plus 0.0092 divided by 12, close the parentheses, and we get that number, 904.451, 904.451, but leave that number in our calculator, because we're going to divide everything by 12 to get our time here. We've got the number in our calculator, divide by 12, and it's going to take us 75 plus years to double. Looking at the nines around, 75.371 years.